A hospital has been tracking the number of incidents of heart disease it treats each year for several years. The data shown below. The data is approximately linear. That's okay. Use the data from 2012 and 2015 to find an equation for the linear model. Use the variable t for years after 2010, so 2015 would be t equals 5 rather, because it's 5 years after 2010. Where n of t, that's the function based on the time, is the number of heart disease incidents. Okay. But it says right here that we need to base it on 2012 and 2015 right there. So we're not using 2013 or 14 at all in this calculations right here, right? And we are looking to write the equation for it. So even though it says it was approximately linear, we're going to force it to be linear because since we're only given 2 points, it's 2 points creates a straight line, okay? The first thing I would like to do is to figure out the rate of change on that, which is the slope. They mean the same exact thing, right? So I would say, well, how many heart disease incidents occurred over this amount of time? Well, that's where you take, and if you've seen the formula for it, right, it looks something like this. You say, well, they ended with 92, they started with 74, and that was for the years 2000, excuse me, 15 from 2012, right? So this creates a formula, well, it's the slope formula, really, that we're using, and we're going to use it now to figure out the rate of change. So calculating this, we'll keep it as a fraction. Let's see, 92 to 74 to 92, it should be 18, right there. And 2015 to 2012, 3 years, right? And of course, this is going to be simplified into just 6, and we'll say heart disease incidents. Yeah, that's a lot of writing. I don't really want to write all that. Per year. Well, why do we need that? It's because it is a slope, right? So the two things we need to write an equation are, or the linear model, the equation of the linear model is the slope and the y-intercept. And right there, we just found the slope, okay? So in that formula, right, it's usually y equals mx plus b, mx, and then plus b like this. Well, we just found m, that's a slope, which is 6. And yes, they said use n of t, and that's fine. We'll change it, but let's figure out what it would be in its basic slope-intercept form first. So from here, next we need to figure out how many heart disease incidents there would have been in year 0, which in this case is 2010, right? So if it's 6 per year, and in 2012, it's that's the value I'm going to use. Oh, that's not what I wanted. There we go. 2012, that's 2 years away from 2010, which would have been year 0. And year 0 is the y-intercept, by the way. Then, well, that's 2 years of 6 heart disease incidents per year, so that's 12 total for the 2 total years on that, right? So the 2 years was 12 heart disease incidents, and so we'll just subtract that from 2012, which had 74 incidents. Where are my markers? Oh, there we go. So they had 74 in 2012, and we're going to subtract 12, because that would have been 2 years earlier, 6 per year, that's 12 over the 2 years, and what do we get, 62? So for the year 2010, it would have shown as 62 heart disease incidents. So now I can go in there and I can replace that B with 62. Let's see if we can make this work. And it's positive 62, by the way, so we just keep it as positive 62. Now this is general slope-intercept form with the y and the x thing. But they did say that they wanted it written where n of t is the number of heart disease incidents, right? So that's not a problem now that we have it written, though, in slope-intercept form. So let's see, n of t, right? So the x is the t, that's the time, and n is the number of heart disease incidents. So that would be our y value on that one. And let me see if I can make the color work here. N of t equals, oh yeah, it's not, I'm sorry, it's not x anymore, it's t, right? X is the time in years. No, yep, years. T plus 62. And there we go. Yeah, so there's part B on that one. So the idea is still the same though, right? Where ours is 146, yours is 136. It's just a matter of where you place it into the formula or this function that they gave us. Well, 146, that's the number of heart disease incidents on that one. I may have crossed that out, not on purpose. That's the N part of that, so that's a 146 right there, which now equals 6t plus 62. Well, to solve this one, 4t, that's what we're really looking for. And even after we solve this, it won't really give us the final answer that we really want. We'll explain that here in a second, so that zeroes that out. 146 minus 62, so that's 4, and then 84 equals 6t, and then divide both sides by 6. So t equals 14? Yep, 14, okay. Well, t equals 14, that'd be 14 years, but it's 14 years after 2010, right? Well, 2010 plus 14 would translate into 2024. I guess we can label it with the year 2024. That seems more appropriate.